So now let's talk about the actual blood clotting and how we form a blood clot. We call this the blood clotting pathway. Now this is going to be our next handout, and it goes through a series of cascades. So what happens is we have different clotting factors, different proteins that are going to initiate and stimulate other clotting factors to produce a blood clot. Now, if we look at this, it says there are two pathways that our body uses to clot blood. We have what's called the extrinsic pathway, and then we have another one called the intrinsic pathway. Whoops, let me go back here. So the extrinsic pathway is going to deal with damaged tissue, like you cut your skin. The intrinsic pathway is going to be dealing with damaged blood vessels. So a blood vessel that's compromised and is forming a platelet plug is going to undergo the intrinsic pathway. These two pathways converge to form what's called the common pathway. And I will explain this with Handout 19H. Now, it's important to understand that the blood clotting is a positive feedback. So remember way back when we first started in Chapter 1, I told you that there are three major positive feedbacks that help our body. All right, the first one was childbirth. The second one was milk production. And now we're finally ready to talk about this third positive feedback system, blood clotting. Blood clotting is going to continue to build on itself in a positive feedback until we've stopped the blood loss, and then it turns off. All right? So it's a good example of a positive feedback. Now, let's get to this handout and talk specifically about what is going on with these pathways. So we have the extrinsic, intrinsic, and then common pathway for blood clotting. Now, what I'm going to do is I'm going to be kind of splitting these up, and we'll talk about each of these one at a time. All right. So here is Handout 19H. And if you look at this, I've got these side by side. We have a side-by-side pathway cascade. So I even wrote that this is a coagulation cascade. And this cascade is going to help clot blood. So we can do this a couple of different ways. All right, now I think to make things easier, we're going to talk about the extrinsic pathway first. And so what this involves is several clotting factors. Now, clotting factors are named after Roman numerals. All right. So this might seem a little bit weird at first, but once you study it, it kind of starts making sense. So the extrinsic pathway is going to be tissue damage. So let's say that you cut your finger chopping up tomatoes, and the tissue, the skin, the epidermis, the dermis is damaged. What happens is the damaged tissue is going to release a clotting factor. Now we call this clotting factor made by the tissue factor 3. See, they've got Roman numerals. Now, what happens is a cascade of events that is going to initiate a blood clot. So, tissue factor 3 is released into the bloodstream. And what it's going to do is it's going to activate another clotting factor called Clotting Factor 7. Now, Clotting Factor 7 is floating around in your bloodstream, but it's not activated. What tissue factor 3 does is it activates tissue factor 7. So this A next to the Roman numeral represents that this is being activated. So tissue factor 3, we could call it clotting factor 3, is going to activate 7. Now 7, once it's activated, it is going to activate another set of clotting factors. Now, it's a little more complicated than that because active 7, along with clotting factor 5 and calcium, see there's a calcium plus 2 there, is going to activate clotting factor 10. So clotting factor 10 becomes activated. All right? So this seems a little bit crazy, and it is. You just have to memorize this. But in the extrinsic pathway, tissue damage releases clotting factor 3. We call it tissue factor. Clotting factor 3 activates clotting factor 7. Then active 7 along with 5 and calcium activate 10. So then 10 is activated. Now, 10 is going to be activating its own clotting factor called clotting factor 2. Clotting factor 2, its inactive form is called prothrombin. Active 2 is called thrombin. So you can see active 10 is going to activate 2. That's a Roman numeral 2. So prothrombin becomes thrombin because of the active 10. All right. Now, thrombin, clotting factor 2, is then going to activate clotting factor 1. So clotting factor 1 is called fibrinogen, and fibrinogen is going to be activated to form the actual blood clot called fibrin. Fibrin is the active form of clotting factor 1, fibrinogen. Now, this is also helped with clotting factor 13. I know these numbers are crazy. 13 is going to help stabilize fibrin and make it into that insoluble blood clot. Okay? So let's go over this one more time just to try and clarify things. So our damaged tissue in the extrinsic pathway, the damaged tissue is going to release clotting factor 3. Clotting factor 3 is going to activate clotting factor 7. Active clotting factor 7, along with clotting factor 5 and calcium, activate clotting factor 10. Clotting factor 10 then activates clotting factor 2, called prothrombin, and turns it into the active form thrombin. Then thrombin, active clotting factor 2, is going to activate clotting factor 1, and this fibrinogen is going to become active fibrin. And the fibrin is your blood clot. All right? This is stabilized by clotting factor 13. So this is a cascade of events. One thing causes another to occur and then another to occur until we make the fibrin. All right. So that is the external pathway. Now, we have another one called, or the extrinsic pathway, I'm sorry. We have another pathway called the intrinsic pathway. Now, the intrinsic pathway is a completely different pathway that forms a blood clot. So it's going to be initiated by the blood vessel being damaged. So now we've sliced the blood vessel. It's going to be leaking out two different clotting factors. It's going to leak out clotting factor 12 and clotting factor 8. So this broken blood vessel is going to activate clotting factor 12. So clotting factor 12 goes from inactive to active. And the same thing is going to happen with clotting factor 8. Clotting factor 8 goes from being inactive to active. Now, again, we're going to have this cascade of events. All right, so ignore 8 for a second, and let's just follow this green pathway where we've got 12. So clotting factor 12 is going to activate clotting factor 11. So clotting factor 11 is activated by clotting factor 12. Then clotting factor 11 is going to activate clotting factor 9 with the help of the active clotting factor 8. So clotting factor 12 activates clotting factor 11, and then clotting factor 11 and clotting factor 8 activate clotting factor 9. Now, clotting factor 9 is going to, with the help of clotting factor 5 and calcium, clotting factor 9 is going to activate clotting factor 10. And then see these merge. So the external and internal pathways merge at clotting factor 10. And so for everything below clotting factor 10, we call the common pathway. So this is our common pathway right here. So now everything is the same as what we just talked about. Once 10 is activated, 10 is going to activate, with the help of 5 and calcium, activate prothrombin into thrombin. And then thrombin is going to activate fibrinogen and turn it into fibrin. All right. So I have a little key down here to help you. It says Roman numerals equal the clotting factors. If you just see the Roman numeral, it's unactivated. If you see a Roman numeral with an A next to it, it's the activated form. All right. So you've got these different extrinsic and intrinsic pathways. All right. Now I know this is kind of weird, but you just got to memorize it. You got to think, okay, 12 to 11 to 9 to 10 with the help of 8. All right. Now, I know what you're thinking, and I agree with you to some extent, where we're thinking, why don't they just name this clotting factor 1 activates clotting factor 2, which activates clotting factor 3, and so on? Why is it 12 activates 11 that activates 9 with the help of 8 that activates 10? This is very confusing. Well, there's a simple explanation for this. The clotting factors are numbered based on not their function, but by the sequence they were discovered. So the first clotting factor to be discovered was fibrin. So fibrin got named number 1. Then prothrombin and thrombin were discovered, so they were named clotting factor number 2. And then our tissue factor was discovered, so it became number 3. Number 4, 5, 6, all the way up to 13. Now, there's something interesting. It says when we number these, there's 13 clotting factors. Calcium is considered clotting factor 4. All right? So if you remember back when we were talking about calcium homeostasis in the bone chapter, I told you that calcium has 3 really important functions, right? The first thing I said, the number 1 important thing, was muscle contraction, and that's what we covered back in chapter 10. Then the second one was blood clotting, and then the third was bone matrix. So calcium is required for us to clot blood. All right. And it's considered a clotting factor when it is in the bloodstream and part of this cascade. So it says calcium is considered clotting factor 4. So if we count these up, we've got 1, 2, 3, 4. Then, of course, you got 5, which is this red one. And then you've got 7, 8, 9, 10, 11, 12, 13. There is one missing. There is one missing. It says, where is clotting factor 6? It turns out that clotting factor 6 was misnamed. It was the, I believe, clotting factor 6. It turns out they thought it was its own clotting factor, but it's just the inactive 5. I don't have 5 being activated. In this diagram, 5's already activated, but the inactive form of 5 was originally named 6. Now we know it's just 5 inactivated. Okay, so this is going to take a few minutes for you to digest this, kind of go through it, rewrite it, write it over and over again, and you'll get it. So the blood clotting, this cascade of events. All right. So let's conclude this by going back to our PowerPoint just for a brief minute. And so you can see the activated fibrin in this picture. This is really a cool picture because you can see the platelet here, and it's formed these fibrin threads that are now the blood clot. So it says the clot's going to plug any ruptured area of the blood vessel, and it's going to remain localized in that area of damage until that damage is repaired, and then we can dissolve the clot. So it says platelets pull on the fibrin threads. So what's really cool is these little platelets can pull and tug on these ropes of fibrin and suture up, retract that blood vessel, and pull that clot together. So the edges of the damaged blood vessels can be pulled together to help promote healing. So actually the production of fibrin, this blood clot, this web or net of protein, can help increase the speed of repair. All right, then it says fibroblasts and endothelial cells can come in and start repairing the damage. All right, so that is blood clotting. One other thing to mention here before we go is that vitamin K is needed to help clot the blood. All right, so vitamin K here is a vitamin that, well, you can get it in food, but it's primarily made in our bacteria in our large intestine. It helps activate several clotting factors, such as Clotting Factor 10 and Clotting Factor 2, prothrombin. Remember, prothrombin is 2. And without vitamin K, we don't clot blood very well. So it says lacking vitamin K prevents blood clotting. So there are some medications that we can use. Oh, whoops, that's not the one. But going back here, there are several medications that people take if they have blood clotting problems that prevent the synthesis of vitamin K. Now, normally we would produce vitamin K to help us clot blood, but some people have clotting issues where they form inappropriate clots. We call these thromboses. And the medications that those people take are going to block vitamin K. One of the most common ones that you may have heard of is a medication called Coumadin. Coumadin is a medication that blocks the synthesis of vitamin K. And when we block the synthesis of vitamin K, we slow down blood clotting because it inhibits the production of Clotting Factor 10 and 2. So that's just an example of that. You'll see that if you scroll down through the PowerPoint slide, you'll see a slide that has Coumadin on there. And what it's doing is inhibiting vitamin K. All right, well, that concludes this handout 19H. So make sure you study it really well, and we'll move on to the next video. All right, have a good one.